Okay, sorry about that. The iPad ran out of storage, so I had to go delete some stuff. Anyway, back to factoring this one. We started with k times k. Last times last has to be 56. So 1 times 56, 2 times 28, 4 times 14, 7 times 8. So I'm looking for a combination that gives me positive 56, so they either both need to be positive or both need to be negative. And my inside plus outside terms have to equal 15k, and that's positive. So that tells me they're both going to be plus. So it looks like plus 7 and plus 8 is going to do the trick. So here is my fully factored problem. K times k plus 7 times k plus 8. Number 4, 2a squared plus 11a minus 90. I want to check to see if there's a greatest common factor. The only thing they have all three in common is 1, so we will not be factoring that out. And then I have 3 terms, so I'm on to guess and check. So I'll start with first times first has to be 2a squared, so 2a times a will do that. Last times last is negative 90, so I'll have 1 and 90, 2 and 45, 3 times 30, 5 times 18, 6 times 15, 7 doesn't go, 8 doesn't go, and 9 times 10. So those are all my possibilities. And I need my inside plus outside to equal 11a, and that's positive. So this one is a little bit trickier. When I start working through my combinations, let's start with, I don't know, 6 and 15. If I try 6 here and 15 here, then for my inside terms I'll have 15a, for my outside terms I'll have 12a. And since one has to be positive and one has to be negative because of the sign of the negative 90, I need to see if 15a minus 12a would give me 11a, which it doesn't. So I will try the other direction, 15 and 6. That gives me 6a for my insides, 30a for my outsides. That does not work either. Since I've tried both orientations, I can cross that off my list. Go on to my next possibility. How about 9 and 10 maybe? 9 and 10 here. 2 times 9 is 18a, 10a. That doesn't work. If I switch them and make it 9 and 10, that gives me 9a and 20a. Oh, and that will work because 20a minus 9a would be 11a. So I need my 20a to be positive and my 9a to be negative. So that'll be 2a minus 9 times a plus 10. Number 5, 6b cubed plus 31b squared plus 5b. Greatest common factor is b for all of these terms. So I'll take a b out. That leaves me 6b squared plus 31b plus 5. 3 terms, so I'll set up for guess and check. First times first needs to be 6b squared. So that could be b times 6b or 2b times 3b. Last times last is 5, so that can really only be 1 and 5. So that makes that choice easy. And since it's positive, they're both going to be the same sign, and since my middle term is also positive, they're both going to be pluses. And I need my inside and outside products to add to be 31b. So in this one I can tell already it's going to be 6b times 5 is 30b, and then b times 1 is 1b. That gives me 31b. So b times 6b plus 1 times b plus 5. Number 6 is 6a squared plus 7a minus 24. Greatest common factor here is 1, so we don't worry about factoring that out. And I have 3 terms, So setting up for guess and check. First times first is 6a squared. So again, a and 6a or 2a and 3a. Last times last is negative 24. So I know I'm going to have a plus minus. And it'll either be 1 and 24, 2 and 12, 3 and 8, or 4 and 6. So I'll start guessing and checking. Remember, my inside product plus my outside product is going to need to equal positive 7a. So I'm going to have to watch those signs. So let's start with 6a times a. How about 3 here and 8 here? That would be 18a and 8a. The difference there is 10, so that's not going to work. What if I switch them and make it 3 and 8? 6 times 8 is 48. That's already too big, so 3 and 8 won't work with 6a and a. How about 4 and 6? That's 4a and 12a. That's not going to work. How about 6 and 4? That's 24 and 6. That also won't work. How about 2 and 12? 2 and 12 would give me 12 here and 12 there. If I switch those, I have 2 and 72, so that's not going to work. 1 and 24 won't work because 24 times 6 is way too big, and if I use it the other direction, I'll have 18 left. So let's switch to 2a times 3a and try those possibilities. How about 4 here and 6 here? That's 18a for the middle, for the inside terms, and 8a for the outside terms. That doesn't work. How about 4 here and 6 here? That's 12 and 12, so that's not going to work. So 4 and 6 does not work. How about 8 and 3? 8 here and 3 here gives me 16a and 9a. Oh, I think that's the one. 16a here and 9a here will give me positive 7a if 16 is plus and 9 is negative. So this will factor to 2a minus 3 times 3a plus 8. Number 7, we have 4m squared minus 9. This has two terms. Greatest common factor is 1. Two terms either has to be difference of squares, sum of squares, difference of cubes, or sum of cubes. This is difference of two squares, so I look to see what times itself gives me 4m squared, and that is 2m, and what times itself gives me 9, and that is 3. So on difference of squares, this is going to factor into 2m plus 3 times 2m minus 3. Number 8 is also two terms. It's 25n squared plus 16. This one is a sum because it's addition. These are squares, so this is sum of squares. Sum of squares, remember, you may or may not remember this. On sum of squares, SOS kind of means, in boating terms, I guess, is save our ship. So it just reminds me of pirates. So when I see SOS, I think some pirates, so some, are attacking our ship, and then we say send out an SOS, and it's aye aye captain. So SOS is the one that has A plus BI, A minus BI. There's the II. So in SOS, it's the I ones. So I look to see what times itself will be 25n squared, and that's 5n. What times itself will be 16, and that's 4. So A is going to be 5n, B is going to be 4. So this will factor into 5n plus 4i times 5n minus 4i. Number 9, 35r cubed plus 5r squared minus 21r minus 3. So I look to see, is there a greatest common factor? No. and then I look to see how many terms. There are 4 terms, so I'm going to be factoring this by grouping. So I'll group together my first 2 and group together my second 2. And I want to look at what's the greatest common factor just in my first group, and that's 5r squared. So I'll take 5r squared times 35 divided by 5 is 7, r cubed divided by r squared is r, plus 5 divided by 5 is 1, r squared divided by r squared is 1, so I have 7r plus 1. And then in the second group, I need to make that match and be 7r plus 1. So what can I divide out to leave 7r plus 1 inside? Well, negative 21r divided by 7r is negative 3. Negative 3 divided by 1 is negative 3. So what I need to take out is negative 3. Then I'm going to group this common parenthesis together, and this is like another common factor. So the common factor between this term and this term is 7r plus 1. So I take out 7r plus 1, and when I take that out, what's left in the first term is the 5r squared. So 5r squared, and what's left in the second term is negative 3. So it will be 5r squared minus 3. I do want to check this squared term to see if it factors, and it's 2 terms, so again it could only be difference of squares, sum of squares, difference of cubes, or sum of cubes. And since 3 and 5r squared are not perfect squares or perfect cubes, that will not factor anymore. So the final answer would be 7r plus 1 times 5r squared minus 3. Let's see if we can get the last 3 problems done in a couple minutes here. Number 10 is 12b cubed plus 10b squared plus 30b plus 25. So we're going to look for an overall greatest common factor. There's not. So then I'm going to group this because it's 4 terms. So in the first group, greatest common factor is 2b squared. So 2b squared out front. What's left in will be 6b plus 5. Then I need to check and see what can I take out to match 6b plus 5. And that is a positive 5. So I write plus 5. And then I'm going to take my common 6b plus 5 parenthesis times whatever's left when I remove that, which will be 2b squared plus 5. So times 2b squared plus 5. Again, check that last parenthesis and see if it will factor, which it will not. So we are done there. Number 11, we have 27m cubed minus 64. This is 2 terms, so it's either difference of squares, sum of squares, difference of cubes, or sum of cubes. Both of these are cube numbers and it's subtractions, so it's difference of cubes. Now remember, on sum of cubes and difference of cubes, the formula for that, if we have f cubed plus L cubed. Remember, we fill it in with F, L, and then F squared, F, L, L squared. And then we fill in the gaps with SOAP. So the first sign is the same as the problem. Second sign is opposite of the problem. And the third sign is always positive. So here we have sum of cubes. For difference of cubes, it's the same formula. We go F, L, and then F squared, F, L, L squared. And then we fill in with SOAP, same sign as the problem, opposite sign as the problem, and always positive. So there's your formulas. Let's go ahead and look at this first problem. What times itself 3 times gives me 27? That answer is going to be 3. And what times itself 3 times gives me m cubed? That is m. So f is 3m. What times itself 3 times gives me 64? That answer is 4. So I'm going to be filling in this formula with 3m for my f and 4 for the L. And I'm out of time on this video, so we'll come back on the next section and do this problem.